So, understand, as we're looking at 2.5, okay, 2.5, we're really kind of doing this really slow, like, workaround of lines. Is that fair? Like, we talked about how do you find slope? And then it's like, okay, how do we graph a line? Oh, we could use a table. And then, what if we put it in slope-intercept form? Or what if we put it in standard form? And just working with them different ways, right? And so really we're focusing on those different things. So today is really focusing on slope-intercept form more. I think the other one we did was graphing using intercepts, right? So the idea is, what if they give you the slope? I always do this. I don't remember. What if they give you the slope and they give you the y-intercept? It would make sense that we would use slope-intercept form, right? Like they gave me these two things, and there's an equation that deals with those things. So let's use that. Okay. So it says write the equation in slope-intercept form. So my encouragement to you is this: anytime they ask you to write the equation of a line, unless they say do it in standard form, this is kind of the default. And so I just try to tell students, that's not what I wanted. Okay. I'll put a little note here for myself. This is going to be a plus or minus. I don't know where the y-intercept is all the time. But like, this is how I'm going to solve these. And every single time, this is always my slope. And this guy is always my y. Yeah. I want to make sure it's the y-intercept, because we were talking about the x-intercept the other day. It's the y-intercept. So we've got our slope and a y-intercept. So they're really nice. They kind of numbered things up here for us. I always feel like the intercept is easiest to find because you literally look at the problem or look at the graph and you're like, oh, it's that number, right? Okay, so it's this guy right here. This is where it crosses the y-axis. Okay, just so we're clear if you're thinking about it. The idea of intercept is like where they're touching or crossing, right? Think in football, because that's what we hear the word interception, right? If I'm trying to pass it right now to Luke, I throw him the ball, and Jack reaches up his hand. He's getting in the way or crossing the path that I'm trying to throw the ball to. So it's the same thing. It's as if the ball is traveling on this path, and then the y-axis intercepts it, cuts it off. Or I think more than football. I would think of like spies, right? Somebody has intercepted the message. Okay. What is this?
He's like the
gotcha.
person.
Number one hire, I told you the other day, mathematicians, the CIA. If I was, I wouldn't be allowed to tell you.
I think he is.
So, this one is a plus, that's the wrong color. Plus 5, that's the y-intercept, okay? And I put this plus or minus because sometimes it's a negative. There's always a sign there for that. The slope, they kind of already labeled for us. I want to be careful because if they label it like this, which isn't normal, because we do read kind of left to right, top to bottom, some students are tempted to put 2 over -3. So just make sure you're careful and you remember slope is always rise over run. Or y over x. Sometimes it's called like the change in y or the change in x. Or I just kind of think through directions. Up and down versus left and right. Okay? So not 2 over -3, but 3 over 2, and it's a negative. Okay? Do we all agree, are we okay that this is the same as this is the same as this? Those are all the same thing. Okay? Yeah.
For our homework design, Google Classroom again.
I'll try to write it at the end of the period.
Okay.
All right. We good with that? Okay. So, if I give you these, again, you're thinking, and your job is to fill in the blanks. Okay? Everybody, eyes up here. We're in like little classroom instruction. This little thing over here controls the pen. So when you come up, and I'm going to call you in a minute to like fill in these blanks, the slope should be
Red.
red. So you click on the little red pen. And then the y-intercept should be blue, so you click on the blue. And it's like circled, or it shows up bigger over here. So when you get up here, if it was like this, like you could see it's yellow. Okay, just so you know what color it is.
Yes.
So understand, like really, not that there's not more details, but this is really what we're doing today. Okay, and I always want you guys holding on to the simplicity of things, so that when they ask you harder questions, you're like, okay, but all I'm really talking about today is y equals mx plus b, y like slope and y-intercept. Does that make sense?
Yeah.
And if you understand the simple one, then what you're going to do is, okay, how do I apply it to these more complex situations? Okay. All right. So, work with the partner. It says find the slope. We're just going to do A. Don't worry about B, okay? So, it says find the slope of each line, find the y-intercept of each line, write the equation of each line. Notice, to write the equation, what are the two things you need? Okay. Slope and y-intercept. So they're really breaking it up. Find the slope of each line and the y-intercept. Yeah? Oh, no, that's a good question. We'll talk about that in a second. Why don't you pair up?
You feel? Yeah.
All right. All right. So that's back. That's back. Okay. Couple quick things. Okay, you should have gotten these answers. Nick made the astute observation, or remembered what we've talked about before, that it says, what do these three lines have in common? Well, because they are parallel, which I would say, like, maybe you didn't know they were parallel. Maybe this was a really good optical illusion. A good way to find out if they were parallel is to see if they have the same slope, which they do. That's how I know slopes are the same, right? And therefore, this is how you write therefore really short. Okay, you put 3 dots in the triangle. Okay, therefore, the lines are parallel. Again, we talked about that before fall break, okay, or fall retreat. So this is just a good reminder for us. Sneak peek really quick to geometry. We never want to assume lines are parallel in geometry, unless they tell us. It'll say like, if they say assume the lines are parallel, or they'll say like they are parallel. If they're not, this is actually one way we can show that they are parallel. Okay, by actually. Yeah.
But if they give you like the equation, then you know that it's parallel.
Right, if they gave you the equation, and they don't always do that. So, all right. This says write the equation for each side of the figure. So really quick, we're not going to do both of these. Okay, again, I'm just trying to put them on there. You guys can always go back and practice them. But these are parallelograms. So I know right away that the slope of this guy and this guy are the same. So let's talk about those two first. Y equals, what's the slope of these lines? Okay, up 1 over 2. Again, if you want to make sure, you go up 1 over 1, 2. If you went from the first point all the way to the end, you would go up 2 over 4. You would simplify and get 1/2. All right? And where does this one cross the y-axis?
3.
Okay, plus 3. I've got this guy here. Y equals, I already know, I just told you the slope's going to be the same. So, great. Where does it cross the y-axis? Okay. Yeah, notice this one. And they're never going to write it like this. I'm writing it like this for a second because I want to talk about it. It does have a y-intercept, and the y-intercept is? 0. Which also happens to be the x-intercept. If it crosses at the origin, the x is 0 and the y is 0, right? But if I take any number, like let's pretend I'm picking a number randomly right now, okay, like 82, and I add 0 to it, what's the answer?
2.
82. So if I take 1/2 x and I add 0, I still get 1/2 x. So they're never going to write this. They're just going to leave you with y equals 1/2 x. And students see this, and you know what? They don't think slope-intercept form. And they're kind of like, what in the world is that thing? They're so used to this that when they see this, it's like, oh, it's different. Okay? Well, the reality is, it's the same. It's just plus 0. Okay, so you want to look for those things so we don't like miss out on that. Yeah.
What about those other problems where it's like horizontal or vertical? Would that be plus 0?
Can I get there in a minute?
Okay.
Yeah, I believe the next slide maybe
Okay.
has an example of that. All right. Let's talk about these guys. All right. They also have the same slope. This is again, it's a parallelogram. So what's the slope of this guy? Y equals 2x up 2 over 1, right? Or down 2 over -1, or up 4 over 2, and simplify. All right. And where does that cross the
0.
y-axis? Yeah, this one also crosses at 0, 0. So I'm going to plus 0. I'm not going to write it. All right. And then there's this guy. All right. I look at this one. I'm like, okay, I know this much. Y equals 2x. Please. Don't just be like, well, it doesn't cross the y-axis. Because technically they're asking you, write the equation for each side. When they say the equation, they're thinking the equation of a line. And lines go on
Forever.
So what you have to do is kind of look at this picture and say, what if the slope continued? Because the slope of this is up 2 over 1, up 2 over 1. What if it continued up 2 over 1, up 2 over 1? How long does it take until I cross
6.
the y-axis? Well, I'm up. You can kind of count the spaces. 1, 2, 3, 4, 5, 6. Okay, so plus 6. Now, this one is a picture that's given to you, and the graph is kind of cut off. But if you're doing something on your homework, obviously you can kind of look at it and say, oh, I've got a lot of paper. I could make my graph, my picture a little bigger, right? I could extend my line and see where it crosses. But just so we're clear, like all we have to do is, like, this would be mean of them, but let's say this shape was like way over here. You'd have to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, like really far. And that could be a possibility. They normally don't do that, but it could be a possibility. And I don't want you to give up because you're like, oh, I never crossed this. It's a line. It goes on forever, so it will. Yeah.
Couldn't there like be a formula like that would be like for everyone that goes over, so it'll like how far you are from 0?
Yeah. You're kind of thinking. However far away you are,
Yeah.
how many spaces will it take me to get? And that is for every 2 you go up,
Yeah.
you go over 1. So again, from this spot, we were 2 away, which means we were going to add 4, double that,
Yeah.
to get there. So you could totally think through it that way. So I'm already up 2. If I add 4 to 2, I get 6. So yes, you can. Again, they're not going to be really mean to you where it's like I was doing just a second ago. Normally it's going to be like, oh, okay, you went up. Like if you looked at this one, same kind of idea, right? Really quick. You know, it's not that far. You go up 1 over 1, up 1 over 1, and you're there. So they're not making you do it like crazy. All right. So here's this one, and the question came up. So really quick, what is the answer to this?
Y equals -4.
Notice the y value here and the y value here are the same. And so y equals, in both cases, y is -4. Like this is the answer. Now, this is in slope-intercept form. Maybe you just don't see it. Y equals, how many up am I going every time?
0.
How many over am I going? 1. Or 2 or 3 or 4. But the idea is, it's 0x minus 4. What's 0 times x? 0. And so like this cancels out. And 0 minus 4 is just,
And it's kind of like the opposite from D, which is like this one doesn't have the X, but the
Right,
other
yeah,
one
this
does
one was
have
like the plus
Yeah.
0, doesn't have the y-intercept. Okay, now the x ones, the vertical lines, those are different because that has an undefined slope where you're dividing by 0 and you can't do. So those are not in slope-intercept form. Right, those are actually what we would say those are not functions. And everything we've been dealing with are linear functions. All right. So now we're saying, okay, like, all right, great, we've done all this wonderful math. What about some like word problems? Because you know every homework assignment, the back end of them is always some word problems, right? And that's where we tend to get stuck. So here's what I want to remind you. Like I said at the very beginning, think simplicity for me. What they are asking you about is slope-intercept form, right? And the slope and the y-intercept. Like those are the things they want to know. So as I look at this, they're like, write an equation. So I'm like, okay, great. Y equals blank x plus blank. The y-intercept is always really easy. Where does this line cross the y-axis? Okay, positive 3,500. Okay, and then the slope. Now, ready? Like I'm going to count slope, right? And I'm going to do it wrong on purpose, so don't correct me and think that I can get extra credit. Okay. The slope that people put very often for this one is up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and they put 1. Problem. You're not going up 1. You're going up 500 every time. Scale, you have to pay attention to. You are going over 1, but the space between all of these, 500. Yeah.
I thought when the slope went down, it was supposed to be
It is negative. I haven't gotten to that yet. I was just saying, like, counting spaces, right? So it is negative.
positive 3,500.
So that's your starting spot, and you're going down this way. So, but again, what I was talking about is I just like making sure we're not just counting like up 1 over 1. We have to pay attention to the scale, right? So, but yes, absolutely. So this is it's negative, and I said you're going up 500 to the left 1, so that's the negative 500. Or if this is better for you, right? Let's pretend I didn't want to count. Just to remind you, there's a formula for slope. I would do this thing, y2 minus y1 over x2 minus x1. So I could plug it in and solve. Y2, let's take this, 1,500 minus 3,500 divided by 4 minus 0. Okay.
2,000.
We're going to bring this down here. We got negative 2,000 over 4. Is everybody okay with that? Like 1,500 minus 3,500? Okay. And 2,000 divided by 4. What is 20 divided by 4? Like, if I ignore this for a second, right? That's 5, and I'm going to add 2 zeros on there. So you get 500. Okay. So there's like a math way to do it. There's also a graph way to do it. The danger with counting is that people put 1 on this problem, or negative 1. Because they're just like, oh, it's up 1 space, over 1 space, up 1 space, over, and they don't pay attention to the scale. Yeah.
Will there ever be a time where the line looks like it looks really like it's on the point, but it's actually like
Not
Yeah.
intentionally like to deceive you.
okay.
So, normally it's pretty clear at this point for what we're doing. Okay. All right. There was a B on this one, right? So this says, how much time does it take to complete the tunnel? Now, I want you guys thinking what they're actually asking. Okay. When they've completed the tunnel, how much distance is remaining?
0.
0. So what they're asking you is, how much time months, x, when y equals 0. Or, the other thing they're asking you is, what is the x-intercept? And I just want you seeing that because, right, a lot of times, students are like, I don't know. And then they give up. They're like, I don't even know what they're asking me. Like, how do I figure that out from this? And some people will say, like, oh, that's really easy. I can look at it and figure it out. But I just want you to see there, how much time? That's x, right? This stuff is all x. To complete the tunnel. That means, again, the distance remaining is 0. Oh, that's my answer's right there. Okay. Now, how much time? 7 what? Months. And so I would ask that you do put the word in there. It's not 7 years. It's not 7 days. It's 7 months. You're like, if it's 7 days, that's really quick. If it's 7 years, it's really long. Okay, so 7 months. Okay, it's doable. It's reasonable. Okay. All right. So 2 things I want to mention about this one. First off, I want you to see that this one should be really easy. That's first. Secondly, I want you to see something that's maybe a little bit more in detail. So first thing I want you to see. What is that coordinate? Yeah.
It's the y-intercept.
This is the y-intercept. The y-intercept is always a coordinate where the x value is 0, and then the other number is some number, right? In this case, it's 5. Okay. The other thing I want you to see about this one is that the y's are the same. And a minute ago, wrong way, we had a graph where the y values were the same. What did our equation look like? Y equals that number. So on this one, my answer is y equals 5. Like this one should be easy. Now let's say I didn't recognize that. And I'm like, okay, great. I do know this is the y-intercept. So I'm like, okay, y equals blank x plus 5. And then I need to find my slope. How do I find the slope given 2 points? Yeah.
y2 minus y1 and x1. Yx2 minus y x1.
X1. There you go. You got it. So I would start to plug in. I'm like 5 y2 minus y1 minus 5 over x2 minus x1. And I'm like, okay, all I have to do is pay attention to the top. 0 over, it doesn't really matter what the bottom is. 0 divided by anything is 0. That was terrible. Okay. 0 times x?
0.
0 plus 5? 5. Okay. So even if you didn't catch this, you should still get the same answer. Does that make sense? But I'm like, hey, really nice time saver. If the y values are the same, then the equation is y equals whatever that number is. What if the x values are the same? What's my equation? That's the slope. But if I ask for the equation of a line? Yeah? X equals, right? And you're recognizing, absolutely, there is no, the slope is undefined, so my equation would look, again, let me just, quick one, let's just say I took these points, and I'll just make up another one. So 8, 10, and 8, 5. Okay? Then my equation would be x equals 8. And that would be a line that looks like this. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Again, shortcut. Both the x values are 8. Okay. So it's a nice vertical line. Okay, I just gave you a free problem.